We live in a world powered by electricity. From the lights in our homes to the smartphones in our pockets, it's easy to forget that complex electrical systems make it all possible. But how do we make sense of these intricate networks of wires and components? That's where electrical diagrams come in, like maps for electricians and engineers. Imagine trying to build a house without a blueprint, or bake a cake without a recipe. It would be nearly impossible. Similarly, electrical diagrams provide a visual language for understanding and communicating how electrical circuits work. They use standard symbols and conventions to represent various electrical components and their connections, making it easy for anyone trained in the language to decipher. These diagrams are crucial for designing, installing, and troubleshooting electrical systems. They allow engineers to plan and optimize circuits before a single wire is soldered. Electricians rely on them to wire buildings safely and efficiently, and when problems arise, these diagrams are essential tools for diagnosing and repairing faults. So, whether you're a seasoned electrician or just curious about the electrical world around you, understanding electrical diagrams is like having a superpower. It allows you to see the flow of electricity and comprehend the inner workings of the technology that powers our lives. Let's dive in and explore some of the fundamental symbols and concepts that form the basis of this powerful language. Every electrical circuit, no matter how simple or complex, is built using a combination of basic components. These components, like the ingredients in a recipe, each have unique properties and roles to play in controlling the flow of electricity. And just like a recipe uses abbreviations for ingredients, electrical diagrams use symbols to represent these components. Let's meet three of the most common components and their symbols. Resistors. Imagine a resistor like a speed bump on a road. It restricts the flow of electricity. The symbol for a resistor is a zigzag line. Resistors are essential for controlling current and voltage levels in circuits. Capacitors. Think of a capacitor as a tiny battery that can store and release electrical energy quickly. The symbol for a capacitor looks like two parallel lines. They are often used for smoothing out voltage fluctuations and in timing circuits. Switches. Just like a light switch in your home, an electrical switch is used to interrupt or allow the flow of electricity. The symbol for a switch looks like a break in a line with another line that can bridge the gap. Switches are found in countless applications, from turning devices on and off to more complex control systems. Now that you know some basic electrical components and their symbols, let's see how they come together in circuit diagrams. These diagrams are like roadmaps for electricity, showing how the components are connected and how the current flows through the circuit. Lines as wires. In a circuit diagram, straight lines represent wires, the pathways that electricity follows. Think of these lines as the roads connecting our components. Connections and nodes. Where two or more lines meet, it's called a node or junction. This indicates that the components connected at that point share the same voltage. Imagine this as an intersection where the flow of electricity can split or merge. Reading the flow circuit diagrams are typically read from left to right, with the positive side of the power source on the left and the negative side on the right. This helps visualize the direction of current flow. Let's put it all together with a simple example. Imagine you want to build a circuit to turn a light bulb on and off. You would need a battery. This is our source of electrical energy. A switch, to control the flow of electricity to the bulb. A light bulb, our load, which converts electrical energy into light. In the circuit diagram, you would see the battery symbol with its positive and negative terminals marked. A line connecting the positive terminal to one side of the switch symbol. Another line connecting the other side of the switch to the light bulb symbol. Finally, a line connecting the light bulb back to the negative terminal of the battery, completing the circuit. When the switch is open, the circuit is broken and no current flows, so the bulb stays off. When the switch is closed, the circuit is complete, allowing current to flow through the bulb, causing it to light up. Understanding this simple circuit and its diagram unlocks the door to more complex electrical systems. By learning to read and interpret these symbols and diagrams, you gain a fundamental understanding of how electrical devices and systems work. So keep exploring, keep learning, and remember, with a little knowledge, the power of electricity can be yours to understand and even control.